Okay, question 4.58 of your textbook asks us to write a general equation for a neutralization reaction. Now, neutralization, also sometimes called acid-base. We want to write a generic general form for how these reactions work. Okay? I like to think of these reactions in the following generic general way. I'm going to write this type of generic equation in words, then we'll come back and talk about it. But for an acid-base reaction or a neutralization reaction, you can usually summarize it as an overall reaction that involves an acid reacting with a base to make water and something that's a salt, okay, or a compound that's considered a salt. So let's consider some examples that perhaps you're familiar with. So probably the most prototypical acid-base reaction that you might see is taking the strong electrolyte and strong acid, hydrochloric acid, an aqueous solution of HCl, and reacting it with a strong base, probably sodium hydroxide being the most common. I guess we could also use potassium hydroxide there, but let's stick with the sodium hydroxide. Acid, base. How can you recognize acids and bases? This is an important concept, actually. There's a list in Chapter 4 of your textbook of common strong acids and strong bases. You should memorize those. It comes in handy a lot in General Chemistry 1 and General Chemistry 2. This is on our list of strong acids. This is on our list of strong bases. Some other things that you can use. If you've got an H+, remember acids tend to donate H pluses in solutions. That could be a little bit of a cue, but it can kind of get confusing because hydrogen can show up lots of places in molecules, some of which don't involve acidic protons, okay? That's probably not the best way to do it. Memorizing the list is a little bit better, okay? Likewise, strong bases you can usually recognize by recognizing the hydroxide anion, OH-1. When you see OH-1 in an ionic compound, you're going to deal with a base of some type. Now, if that's paired up with a group of 1 element, as it is here, certainly a strong base, okay? Meaning the ions will separate completely when in solution. Strong electrolyte as well. Now, when the acid-base chemistry occurs, what do we make? Generally speaking, you always make water in such a case like this, okay? Now, how does that work? Well, the OH pairs up with the H+. So the key ions here are the OH and the H+. The OH- and the H+ come together to make water, H2O. And of course, that's a liquid. The other compound that's produced is a salt. Now here, that salt is NaCl aqueous. That's consistent with table salt as well. All right, but it doesn't have to be sodium chloride. It can be other things. For instance, what if I started with HBr aqueous, also strong acid, and I reacted it with KOH. Now, the H+ and the OH- is still going to make water. Salt will have a different identity. Here it's going to be KBr, or potassium bromide. Chemists would still call this a salt, even though it's not table salt. A salt is basically just an ionic compound in chemistry lingo, okay? But you can see that for both of these reactions, this overall scheme is conserved. Acid plus a base makes water and a salt. And this is characteristic of a neutralization reaction.